On the 17th of August, 1966, the only prototype to have flown of Britain's most advanced aircraft project was towed down this road. It flew just 24 times, and the £200 million that had been spent on its research and development was eventually to be reduced to just £50,000 worth of scrap. What remains today of the TSR2 project can only be found in museums, standing as testimony to the decisions that sealed its fate. Conceived in the 1950s, designed and flown in the early 60s, the story of TSR2 is one of technological triumph and human endeavor. It was an aircraft years ahead of its time. The years 1950 to 1957 could be described as the post-war golden age of the British aircraft industry. Shop floors were full of priority orders resulting from the Korean War panic. Design officers were working flat out on a whole series of advanced operational requirements for the RAF and the Navy. The Farnborough air shows revealed a procession of advanced prototypes and piloted scale models of shapes to come. Then, in 1957, the Secretary of State for Defense, Duncan Sands, presented his Defense White Paper to Parliament, which called for the elimination of manned aircraft in favor of missile systems. This left Britain's aircraft industry and the Royal Air Force with just one key project to pursue: the replacement of the highly successful and widely exported Canberra bomber. Meanwhile, the Royal Navy had not been idle in identifying its requirement for a low-flying strike aircraft. In 1955, Blackburn Aircraft won the contract to develop the NA-39 Buccaneer, a twin-seat carrier-borne strike aircraft capable of flying under the enemy's surface vessel radar screen. The Navy had a powerful ally in Lord Louis Mountbatten, who, as Chief of the Defence Staff, whilst this would have helped to reduce the costs for the Navy and ultimately the Air Force, the RAF felt that the Buccaneer would not fulfill their requirements.
Now, it was built for mainly for low-level work, but the point was that
they proposed their P-17, provided with a VTOL capability by the P-17D from Shorts, who'd been gaining valuable experience in vertical takeoff with their SC-1.
The prime contract was given to Vickers. It's true to say that their experience lay in subsonic aircraft and in civil aircraft. The only military plane, I think, that they built was the Valiant bomber, which had manifest structural faults in design and was in fact withdrawn after 5 years, so you could say it was a failure. And yet, in spite of the contrast between the two firms,
Hampden and Halifax bombers under license from Handley Page during the war, and then on the basis of that, a new design team was formed in 1945 specifically to design and build for the RAF its first jet bomber, the Canberra. English Electric were regarded as newcomers by the rest of industry, and I think slightly resented for that.
By any standards at that time, TSR2 was to be the most advanced aircraft in the world. It was to be capable of around Mach 1.1 at 200 feet and Mach 2 at medium and high altitudes with a radius of action of 1,000 nautical miles. The aircraft would need a completely new, fully automatic radar system, more advanced than anything else in existence, including terrain following and sideways-looking radar with automatic updating of data. It was to be capable of taking a full reconnaissance fit, operate from short strips in all weather, and provide everything from long-range nuclear strike to battlefield support. No self-defense weapons were initially proposed, although there was a provision to carry 4 air-to-surface rockets. The government's choice of the Bristol Siddeley Olympus engine was a controversial decision and was to lead to delays and massive cost overruns. Problems with the engine would prove difficult to resolve and were not identified until after the first flight. The Vulcan Olympus flying testbed would later blow up whilst taxiing. The government placed the contract for 9 pre-production aircraft with the Vickers English Electric Consortium in October 1960, more than 18 months after the contract had first been announced. In spite of mounting opposition from the Navy and the Treasury, Britain's most ambitious aircraft project yet devised had been given the go-ahead. Vickers, under Sir George Edwards, was to be the prime contractor and responsible for the front fuselage section, which included the cockpit, weapon systems and budget control. English Electric, led by its chief designer, Freddie Page, was to concentrate on the aerodynamics, wings, tail and rear fuselage. From an early stage, the consortium responded to the project's critics in Whitehall by illustrating their design philosophy, as seen in this film extract presented by their chief project engineer, Ollie Heath.
Flaps with a tailplane so designed as to release the whole of the wing for flap blowing, the provision of adequate thrust-to-weight ratio secured by powerful Olympus 22R engines, giving a thrust-to-weight ratio of 0.6. The requirement for rudimentary field operation by large wheels, which despite the requirements for low cross-sectional area, are stowed within the aeroplane without drag penalty. The crosswind requirements met by the large parachute, which of course also confers the short landing facility.
The advanced technology of the aircraft was mirrored in the complexity of the manufacturing, which was to employ new working practices and advanced materials. Other problems relating to project management control would lead to delays. After more than 5 years' work, the first prototype, XR219, was transported in sections to the Aircraft and Armament Experimental Establishment at Boscombe Down in Wiltshire, where it would take 3 months to assemble. The choice of Boscombe Down as the site of the flight test program was a compromise solution. English Electric's base at Warton in Lancashire would have been an ideal support and maintenance base. Vickers had wanted the first flight to take place from their airfield at Wisley. Roland Beaumont argued that the Wisley runway was too short. Working from Boscombe Down would create more problems.
We had the worst of both communication worlds. We were 150 miles from Warton and 60 miles from Weybridge, where we ought to have been doing all that work on one base with all the experts just round the block.
The sum total of delays and resultant cost increases that were plaguing the project meant the planned in-service date had to be put back. This news poured further fuel on the fire of mounting opposition from the project's critics. The newly assembled and freshly painted TSR2 was wheeled out in September 1964 to commence its engine runs and taxi trials. Roland Beaumont and other members of his flight test team still had nagging concerns about the unresolved engine and undercarriage problems. The continuing build-up of political pressure and adverse media criticism was heightened by the looming general election, with the ruling Conservative government looking set to lose. Meanwhile, a meeting was convened at Boscombe Down. In view of the October election and the Labour Party's uncertain support for the project, the question on everybody's lips was, when could TSR2 make its first flight? A successful flight before the election might prove critical